friends, today I'll be making another video on the subject of applied mathematics for engineering, and today we will discuss on how to solve a second non-homogeneous second order ODE. So you might actually need to watch other videos on how to solve a homogeneous second order ODE, but I haven't made that video personally, but I'll try to do it later. And if you want to know more about it, you can go to other channels or search the internet on how to solve a homogeneous second order ODE, but I'll mention a little about it later. So let's go into a sample question. So suppose we have a non-homogeneous second order ODE of y double prime plus 5y equal to 0.02 x squared, and we want to find the general solution of this second order non-homogeneous ODE. So what we want to do is that the general solution yx is equal to the homogeneous solution of this equation plus the solution choice, which later is known as the method of undetermined coefficients, which we will discuss later. So what we want to do is we need to analyze yh first. Yh is the homogeneous solution. Finding yh, we change these variables by using lambda. So lambda squared plus 5 lambda is equal to 0. So this equation over here is called a homogeneous equation because it doesn't have a result, or the result Rx here is 0, while in this solution we have 0.02 x squared as our Rx. So we need to find this solution over here, and we know that if we have these types of equations, we're going to have three characteristics or three conditions. So the first case is that lambda is real, and different. So the homogeneous solution will be A, which is any coefficient, exponent lambda 1x plus B exponent lambda 2x. The second case is when lambda is real and it's a twin. So lambda 1 equals to lambda 2. The homogeneous solution for this case is exponent lambda x times A plus bx. And the third case, lambda is an imaginary root which consists of r plus I omega, and the homogeneous solution for this third case will be exponent Rx times A cosine omega x plus B sine omega x. So there are three cases depending on what equation you have over here, but in our case over here we see that whoops, this is not supposed to be plus 5 lambda. Let me erase that. should be plus 5, because lambda squared is symbolizes for y double prime, and lambda symbolizes for y prime, and no lambda just symbolizes for corresponds to the coefficient. So until here we need to evaluate lambda. So finding lambda is just pretty simple. You can always use this equation, minus b plus minus square root of b squared minus 4ac over 2a. So if you're using the applied mathematics with from Kreyszig, you can see the coefficients of a, b, c are pretty different, but I'm personally going to use my own coefficients over here because for me it's more simpler. So over here we have our a is equal to 1 because it is the coefficient of lambda squared, 1, and our b is equal to 0, and our c is equal to 5. So you can pause the video and write these 3 cases if you have skipped the homogeneous part, and I'm going to clear this. So continuing our calculations, so lambda is equal to minus 0 plus minus the square root of 0 squared minus 4 times 1 times 5 over 2 times 1, which gives us plus minus the square root of minus 20 over 2, which finally gives us plus minus the square root of 5 times I. So we have our lambda here, we have our root, and as our prediction, it is the third case, as it contains imaginary roots. So remember this form, the r plus minus I omega. So we have our r is equal to 0, and we have our omega is equal to the square root of 5. So the homogeneous solution of this case is equal to exponent rx times a cosine omega x plus b sine omega x. So this equals to 0 exponent 0x, which we can cancel out as any number power to 0 is equal to 1, times a cosine square root of 5x plus b sine square root of 5x. So we already have our the homogeneous solution over here. So the next step that we want to do is we need to find yp. As mentioned before, yx is equal to yh plus yp, and we already accomplished yh, and now we need to find yp. So you could copy this yh first, a cosine square root of 5x plus b sine square root of 5x. So I'm going to clear this. So finding yp requires a table, which is a method of undetermined coefficients, where this is the table over here, terms in Rx, choice for ypx. So you can look it up in your book or in any other internet source, but I'm just going to rewrite it. So these are the forms of Rx that could be expected. So basically these are the possibility terms of Rx and the choices for ypx over here. So in our case, in our question, let me rewrite the question over here. Y prime double prime plus 5y is equal to 0.02 x squared. So this is our Rx over here. So looking it up in the table, it matches with this column, right? This row over here. Oops. So we're going to transfer this form into this form over here and evaluate yp to complete the general solution. So writing things again, so yp, we choose this part. So the x is the power of 2, so we're going to make it yp is equal to k2 x squared, because kxn, small k, and this is capital K. So our x is over here is to the power of 2, so k2x squared plus k1x plus k0, because it immediately went to k1x, so we don't need to bother about this form over here. So we have yp k2x squared plus k1x plus k0. The next thing we want to do is we're going to find, since this is the second order differential equation, we need to differentiate it 2 times. So yp prime with respect to x is equal to 2k2x plus k1, and yp double prime is equal to 2k2. So looking back to the question over here, this requires y double prime plus 5y, so we're going to substitute y double prime with yp double prime, and we're going to substitute y with yp. Since it doesn't have y single prime, we don't actually need this part over here. But if there is a y single prime, you could always substitute it with this form over here in other cases. So substituting it, we're going to have 2 k2 plus 5 times k2x squared plus k1x plus k0 equal to 0.02 x squared. So let's clear things again. And let me just rewrite that for you. So we have 2k2 plus 5k2x squared plus 5k1x plus 5k0 equal to 0.02 x squared. So now what we want to do is we want to match the coefficients. For example, if we have x squared, we need to match the left hand side and the right hand side with the same coefficient. So it is not the same coefficient, but it needs to be balanced. So we have x squared over here and we have x squared over here, and the coefficient of x squared is 0.02 in the right hand side, while we have 5k2. So we need to match this part over here and this part. So 5k2 is equal to 0.02. So k2 is equal to 0.02 divided by 5, which is equal to 0.004. So we have our k2. Now we need to evaluate k1. So in the right hand side we don't see any coefficients of x, so k1 is simply 0 because this doesn't have its match over here. So last but not least is we need to evaluate k0. Since we don't have any extra coefficients over here, so the total of 2k2 plus 5k0 must equal to 0 to make it balance. So 2k2 plus 5k0 is equal to 0 because you don't have any extra coefficients over here and you only have coefficients of x squared, so you don't need, so the total of the random coefficients over here, 2k2 plus 5k0, must be equal to 0. So k2, we know k2 is 0.04, I mean 0.004, so substitute it. 0.0004 is equal to minus 5k0, and k0 is equal to 0 minus 0.0016. So we're writing yp. We have yp is equal to k2x squared plus k1x plus k0. Since k1 is 0, we could cancel this part and write the coefficients of k2 and k0. k2 is 0.004 x squared from here, plus k0. k0 is minus 0.0016. So we already accomplished YH and YP. Now we have our general solution. YX is equal to YH plus YP. Remember, our YH is equal to exponent, it's 1, so doesn't matter, a times cosine square root of 5x plus b sine square root of 5x, that's our homogeneous solution, plus our yp plus 0.004 x squared minus 0.0016. So this is our general solution over here. We have accomplished it. And in some other cases, if you know the initial value, which is also known as the IVP problem, you could actually input x as 0 and for a certain solution, and you could evaluate a and the b coefficient over here. But in this case it's not as, so we are just required to find the general solution, so it doesn't matter to write in these two coefficients a and b. So maybe I'll make another example of it for an initial value problem, but until now that's how you solve a second order non-homogeneous ODE. So hope you like the video, and don't forget to like and subscribe to my YouTube channel for more tutoring videos, and please leave any comments for the video, and if you have any questions you can just post the question in the comment box, and hope to see you soon. Bye.